challenge is called Convert to Binary. The task overview reads, given a non-negative integer n, write a function to binary which returns that number in a binary format. Remember, binary is a base 2 numbering system consisting of only ones and zeros. So, kata to binary method returns the binary representation of a non-negative integer as an integer. That would be base 10 value that they're looking for, the normal numbering system that we use in regular everyday speech. So, yeah, that's syntax there. They've got some values here. The binary representation of the argument as an integer should return 1. Notice that 5 is 101, 11 is 1011. And so, yeah, if you want to think of these, this binary base 2 numbering system, remember starting from the right here, where the decimal point would be, you could think of it as the value here representing the base to the power 0, in this case 2 to the power 0, so it's the ones place. Normally the second one would be the tens place in decimal, but in binary that would be 2 to the first power place, which is the twos place. This position would be 2 to the 2, or 2 squared place, which is the fours place. And so if you consider that there's a 1 in the fours place and a 1 in the ones place, you see 4 plus 1 adds up to 5. And then you can do the same thing for 11. Notice this third place though would be out 2 to the 3, 2 cubed, which is 8. So you've got it 8. You've got a 1 in the twos place, which brings you up to 10. And you've got a 1 in the ones place, which brings you up to 11. So if you're shaky with binary numbers, that could be a good exercise to get comfortable with them. You don't need to be able to, just rattle those off the top of your head, but it's good to know the process and kind of understand how that numbering system works. So we'll get on with the fix now. Go ahead and pause it and write your own. They're going to give you the value in our normal base 10 numbering system, and they're looking for something back that looks like a binary, ones and zeros. So go ahead, come on back when you're ready. So for my solution, we're going to go back to that convert class that we've used in the past. My process is going to be basically to convert the input into a string. This convert method has a way for us to readily get to a binary form, and then I'm going to use the integer parse class to go back to an actual integer type. We're going to convert that string to the integer type. So if we go over to convert, the convert class, that's what I'm in right now, you see it has this toString method where it takes two values. The value in question, which is our parameter that we get passed in, and then we can specify whatever base we want to convert it to. Just note that you're limited in what you can put in that base, and it's to the very common base values that we work with. 2, which is binary, 8 is octal, 10 is what you know, and 16 is hexadecimal. I think we did a challenge with hex too. So yeah, go check out the examples if you want to see that in action. See numbers being converted there. Good stuff. We'll go back to the challenge then. String binary equals convert. Sorry. ToString was the method name, and then it took our input integer, the value that we want to convert, and then the base. I'm going to specify 2 for binary. If you want, you could type this out if you want to see what it is at this point. Not necessary, but you can. And then finally, so at this point, this method got us into the binary form, but remember our type is string. The contract says we need to return an int. So let's go back to an int now that we've changed this into a binary form. And you can use int32. It has a parse method that I'll use for this. We can go over here. This is the try parse method. I was going to show you if you want it to be. This gives you a better chance to handle the situation where your number isn't parsed out correctly. And then you could consider it an introduction to out parameters. So it's going to try to convert value, the string that you pass into a number, but you can imagine if it has letters, you know, that aren't even hex characters or some punctuation marks or some other gibberish, it could fail in trying to parse this out into a 32-bit sized integer. Or imagine a really large valid number might not fit in a 32-bit integer. So, you know, you can then, you get this flag saying whether it was successful or not, and yeah, proceed accordingly. If you are successful, if you're not, you could throw an exception or do whatever you have to do. So that's that idea. There's a simplified version of it if you don't like this one. That's just parse. And then notice with the out parameter, right, we had to make our own variable, and then this method sort of loads up that variable we made. We didn't even initialize this. We just pass it to the method, you know, as a sort of a reference, and then the method will go ahead and load that number up for us if it can. There's a simplified version that's just called parse. Let's see if we can get the, go with this overload with just a string, where you just pass the value and you sort of assume it works. Notice in this case they use try and catch blocks, so that's another way to handle an error in parsing values. So yeah, you can use parse or try parse, whichever one you want to have a go at. And then we simply give it the binary value. I think if we run this, we're in good shape. Looks good. If you want to expand these and, you know, see what the binary value came in as, notice the argument was 1, we got 1, 2, and binary is 1, 0, right? This second spot, which is normally the tens place, is the twos place in binary, so that looks good. 2 plus 0 is 2. 3, I would expect 1, 1, right? 2 plus 1. And then they have a 5, which we saw in one of the original examples, I believe, 1, 0, 1, which is 4 plus 1. So yeah, those look good. I'll get rid of the print statement. You don't really need that. You could probably, if you want to do it in one line, you could even take this, not even create the string variable. This will probably work. I don't see why not. We'll run the attempt. And good. Yeah, they ran some other tests here. So yeah, we'll go ahead and submit, see what other people did. That looks a lot like what we did. So they used, instead of, I used integer parse for this thing, they just used convert again to take it back to an n. Seems good. These people did it like we did it. This guy stayed, or girl stayed in integer form. So that's kind of cool. That could be a good exercise if you wanted to work with the numbers itself. It's more complicated than you had to make it, but it's a good exercise. Nothing against that answer. Yeah, back to what we did. So hopefully you found this helpful. Hit me up with questions. Otherwise, we'll keep moving. Thanks.